All right. So today we get into something that's called translation. Okay. So a transformation is a change in, there's three things: size, location. Okay, that's when we move stuff. That's what we're going to deal with today. Size is more when we get into dilations and stuff. Or orientation. Orientation of a figure could be like turning it, moving it, not just moving it in the same shape, but turning it or reflecting it. Thank you. Did you get one? Is there an extra one there? You're welcome. So a translation is a form of transformation which slides each point of a figure the same distance and in the same, what do you think this word could be? Can I guess? So if we have a figure on a graph and we slide it somewhere, same distance and same position, direction. Good. The resulting figure after a transformation is called the image of the original figure. So again, you can kind of see it down here. You can see like if you're doing a triangle and they call it ABC, the image triangle would be written as you see it down below. Image of A, image of B, image of C. It's like a little apostrophe mark is used to note the word image. Okay, so kind of like the second figure after we move it. All right, so here's what all this means. So we have a triangle sitting right there, right? And it says that the triangle ABC is translated 1 unit right and 4 units up. Draw image ABC. So we can start at A, right? So if I go 1 to the right, which direction is right? Right? So we're going to go here, and then up 1, 2, 3, 4. And our new point, A, our image A point is right there. What coordinate is that? What coordinate is that? Where I drew that green dot at. Because we got to put that in here. So what's our new A coordinate, Tim? 2, 1. Okay. Now try to do that with B. 1 unit to the right and 4 up. Where should that be? If I go 1 unit to the right and 4 up, what coordinate should it be, Madeline? Right, 4, 4. Right there. And then C. If I move C 1 unit to the right and 4 up, where would image C be, Vanessa? Right, 5, 2, because we go 1 and then up 4, which puts us right there. So here is our new shape. So it's basically what we did is we took this whole figure, moved it right, and then shifted it up. We slid it in the same direction, the same distance, at every point. So if we were to write a rule for this, as a general rule, a translation could be written as XY. So we move a coordinate. We move the coordinate to the right, right? X goes right and left, right? So plus is to the right, minus is to the left. We moved it plus 1 to the right, and then how many up do we go? 4. 4 up. So all the Y points went plus 4, all the X points went plus 1. If it was left and down, it would be a minus here. Pretty easy? Yeah, not too bad. All right, so I'm going to pause this real quick. I want you to try example 2. Okay? So, and that includes drawing the original figure as well. Okay? So you're going to draw J, K, L. These are the original points. And then you're going to translate it 4 units to the left and 5 units up. And then write down your coordinates and see where you come from, where you get to. We'll give you about 5 minutes to work on this, so I'm going to pause. All right. So, if this is what the original figure looks like, right? JKL, and we have to draw the image figure, going 4 units to the left and 5 units up. Where would the image J point be? I need someone new now. Where would the new image J point be? Ella? Good. -4, 7. Because again, we go from here, we go 4 units left, which puts us at -4, right? And we're 5 units up. We're already at 0, 2, right? So 5 units up from 2 is 7, right there. And that's where our image J would be. How many people had that spot? Good. Liking this? This is pretty easy. All right, what about image K? If we're at 3, 4, and I got to go 4 left and 5 up, where does that put me? Joe? Good. -1, 9, which is way up here. That's image K. And then what about image L? Claudia? 1, 6. Very good. And 1, 6 would be right there. So there is your translated image. Notice how it's in the same direction. It's the same size. All we did is take this blue figure and slid it left, and then we slid it up. Okay?
What do we have to do? Like, I don't. What does this do? Like, are we solving a problem? Or are we just
These are called, all these different things that you're going to learn. You're going to learn a dilation. You're going to learn a reflection. You're going to learn rotation. These are all forms of what we call transformation, transforming an object. Okay? This is probably, out of the 4, probably the easiest one. Not that the other 4 are difficult, but this one is pretty simple. Okay? All right, let's go to the table down below. This is just geometry. Oh, so let's go. What was our rule? So how can I write the rule here? For the last problem, example 2. Vanessa, what was the rule for x? Okay, so instead of saying x plus -4, we're just going to write x minus 4. Because the minus means we go to the left. And then what's our y rule? Who can tell me my y rule? Tim? Y plus 5. Very good. So when you see this, you know you go 4 to the left and up 5. That's what that rule means. Okay? So it says, tell me more about this figure. Is it congruent or similar? Explain how you know. What does the word congruent mean? You have an idea? You'll hear a lot of this in 10th grade when you take geometry. You're going to hear this word almost as much as you heard slope this year. The same, equal. Similar doesn't mean equal, right? It means they look the same, but they're not the same, right? So congruent is, so would you consider these up in example 2 and even example 1, the figures to be congruent or similar? How many people think they're congruent? Good, that's everyone. Yeah, they are. They're congruent. And what makes them congruent? Their angles are the same, right? Triangles have 3 angles, right? Because nothing changed, right? So the angles and sides are the same. All we did was we just changed location, right? We didn't change the size of the shape. We didn't change the direction it was going. All we did was take the shape and we moved it to one different side of the graph. That's all we did. So again, when we had this little table here, so again, when we add the x-coordinate, we move to the right. Subtract moves it left. Right? When we add the y-coordinate, what does that do? Moves it where? Up. And then the subtracting moves it down. Okay, last one I want you to try is on that last page there, example 3. Okay, so you're given a triangle. It's pretty long. But now instead of the translation part, they give you the rule. X minus 3, y minus 1. So now let's see what you can figure out. And what are the new coordinates? And of course, too, in words, describe, tell me what the rule is asking you to do. So I'll give you guys a few minutes with your teammates to work on that one. All right. So, what does the rule tell us? What does this thing right here tell us about the figure? Kevin. Right, we move left 3, down 1, right? So if we draw the original figure, t is at 0, 3, 2, 4 is u, and v is 5, negative 1. So this is a long, skinny triangle here. Oop, missed. Wonder if it'll let me. Nope. Get a better angle here to get over. Okay. So if we move down 3 and over 1, where is image T going to wind up at? Where is this point T going to wind up at? Its new area. Negative 3, 2. Good. Because remember, we go to here, and we move left 3. 1, 2, 3. And then we just go down 1 right there. What about image U? Where's that bad boy going to go? Somebody different. Jordan, where's the image U going to go? Negative 1, 3. Very good. And negative 1, 3 is right here. So you can see it's pretty slight sliding over to the left, right? And then image V. From this point right here, where is this going to end up at? Where is that going to end up at? Marco. 2, negative 2, right there. And there is our new figure. All right, so for the rest of the hour, you can work on your little packet there. I'll get these notes up on the website.